Okay, so today we're going to be looking at page 11 in your Unit 4 packet, and we're specifically looking at numbers 1 and 2. But again, we are talking about exponential growth and decay word problems. So let's just recap some important information. We know that y is equal to a times b raised to the x is the formula we're going to be using. We know that a is the initial or the start amount. We know that our b is our growth or decay factor. Now, if we're dealing with a specific rate, our rate is usually either percent or a decimal, but if we're dealing with a specific rate, that b gets branched off into 1 plus or minus r. So we use 1 plus r when we're dealing with a growth, but we use 1 minus r when we're dealing with a decay. And of course, our x is in fact our time. So let's go ahead and jump into this problem. It says you buy a house for $130,000. It appreciates at 6% each year. How much is it worth in 10 years? So we have to first determine whether or not this is a exponential growth or a decay. Well, if it's appreciating, that means its value is going up. So we're definitely going to be dealing with an exponential growth. What's our initial amount or our start amount? Remember, that is our a in the formula. But our initial amount is actually 130,000. So I'm going to put 130,000. And again, that is my a. And then it says, is it a growth or a decay rate? Well, we already indicated that it was a growth. Now we have to look at our rate. Remember, we said our rate is actually a percent or a decimal. So the percent that they're giving us is actually 6%. So 6% would be our growth rate, or that's equivalent to 0.06. We can move the decimal place 2 to the left, or we could simply just take 6 and divide by 100 and get 0.06. So now we have to determine whether or not we have a growth or decay factor. Again, it's an exponential growth, so we're going to be dealing with a growth factor. The factor is our b, so it's either going to be 1 plus or minus r. Because we're dealing with a growth, that means we're going to be doing 1 plus our rate. So we have 1 plus our rate, we just said, was 6%. So in our calculator, if you have the TI 36X Pro in your calculator, you could simply just hit the 1 plus the 6, and then to get your percentage sign, what you can do is you could hit second, and then you can hit the division button, because on top of the division button is your percent sign. So when we do that, we get 1.06, or you could have just simply added the 1 plus the 0.06 and got the same answer. Either of the two is acceptable. Now what they're asking us to do is to write the function for this situation, right? Well, we know that the function is actually y equals a times b raised to the x. Well, we have y, which is equal to our a, which is our starting or initial amount, which is 130,000. And that's going to be multiplied by our b, which is our growth or decay factor. Well, we just found that. That was 1.06. And then it needs to be raised to a power of x in order for it to be considered a function. So y equals 130,000 times 1 600 raised to the x power. That would represent our function. Now they're asking us, how much is it worth in 10 years? Well, that 10 years is our time. So our t, or our x, because our time is x, is equal to 10. So what I'm going to simply do is take my function that I just created, which was y equals 130,000, times that 1 600, and now instead of my x, I'm simply going to put that 10. So when we do that, now we can just go straight calculator. So we're going to put this in the calculator, in the regular part of the calculator. So we're going to do 130,000 times that 1.06. And then to raise it to a power, we're simply going to hit that x to the box button. So x to the box, press that. And then we're simply just going to input the 10. And when we press enter, we end up getting approximately, that little squiggly line just means approximately, 232,810.20. So what's going to happen is, because we're dealing with money, I'm going to round 2 decimal places. So our approximate answer is going to be, actually 1, 2, 3, comma, $232,810.20. And again, we're dealing with money. So let's analyze the situation. He bought a house, he or she bought a house for $130,000. It appreciated or increased 6% per year. And they wanted to know how much was the house going to be worth in 10 years. Well, he started with an initial value of $130,000. And then after 10 years of it appreciating at 6%, his house is now, he or she's person's house is now worth $232,810.20. All right, so let's go ahead and tackle problem number 2. Problem number 2 says, Coach is losing 20% of his hair each year. If he currently has 1,546 hairs on his head, about how many hairs will he have left after 10 years? Quite comical. So right now, we're trying to decide whether or not this is an exponential growth or a decay. Well, if he's currently losing hair, that losing factor indicates that he's losing hair. That means it's definitely a decay. So we're dealing with the exponential decay. So what's our initial amount? Initial amount is what we're starting with. Well, he started with 1,546 hairs. So we already said that we're dealing with a decay. So now we have to talk about our decay rate. Remember, your rate is your percentage or a decimal. So our rate is going to be 20%, or that's equivalent to 0.20. Again, take 20 divided by 100, or there's an imaginary decimal behind here. Just move it to the left. And now we have to determine our decay factor. Remember, our decay factor is going to be 1 plus or minus r. Well, in this case, because we're dealing with a decay, it's going to be 1 minus r. Well, our rate was just 20%. So if I take 1 and subtract it by 20%, again, to get the percent sign, you hit second and the division sign. We end up getting 0.8 or 8/10. So our decay factor is 8/10. So it says to, what's the function for this situation? So again, we go back to y equals a times b raised to the x. We know our a is our starting amount or our initial amount. So 1,546, that's our a, times our decay factor. Remember, it was a decay, so we had to subtract the 20%, and we're left with 8/10. And then we're going to raise it to our exponent of x. So this is our function. Now it says how many hairs will he have left after 10 years? Well, the time that we're dealing with is 10, and our time in this case is represented by the variable x. So I'm going to go back to my function, which is y equals 1,546 times 8/10. And now instead of x, I'm actually going to input that number 10. And now we just go straight calculator. So in our regular part of the calculator, we're just going to hit 1,546 times 0.8 or 8/10. And then we're going to hit, again, we're going to hit that x to the box button, and then we're just going to simply input 10, and so we end up getting 100 and approximately 166.0004. Well, we're talking about here, so we're going to round to our nearest whole number, which is going to be 166. So our answer is 166 hairs. Okay.